Seasons are one of the most gentle and quietly powerful rhythms that shape life on our planet, creating a continuous cycle of change that unfolds slowly and predictably throughout the year, bringing with it subtle transformations in temperature, daylight, atmosphere, and energy that influence not only the natural world, but also human life in deeply interconnected ways. And as we begin to understand this calm and beautiful process, we realize that the story of the seasons is not simply about cold winters or warm summers, but about the graceful movement of our planet through space, moving silently in the vast emptiness of the solar system as it travels around the sun in an endless orbital path, while at the same time spinning slowly on its tilted axis, creating the changing patterns of sunlight that gently warm different parts of the Earth at different times of the year, allowing some regions to experience longer days filled with bright and direct sunlight, while others receive softer, shorter periods of light that bring cooler temperatures and longer nights. And as this balance shifts gradually over weeks and months, the environment begins to respond in peaceful harmony, with trees adjusting their growth, animals modifying their behaviors, oceans changing their surface temperatures, winds shifting their directions, and ecosystems quietly adapting to the new flow of solar energy that arrives from above. And it is within this slow dance of motion and light that the familiar experiences of spring, summer, autumn, and winter emerge, not suddenly but through a gradual transition that often goes unnoticed in daily life, yet holds profound importance for agriculture, weather systems, biological cycles, and even the emotional rhythms of living beings. Because as sunlight becomes more abundant in certain months, plants begin to photosynthesize more actively, releasing oxygen and supporting life. While during colder periods when sunlight becomes limited, growth slows down and nature enters a resting phase that conserves energy for future renewal. And this natural cycle has continued for millions of years, long before human civilization ever observed the changing length of shadows or the quiet arrival of frost on winter mornings, guiding migrations of birds across continents, influencing ocean currents deep beneath the surface, and even shaping the climates of entire regions through the redistribution of solar heat. And although it may seem as if the changing seasons are simply the result of the Earth moving closer to or farther from the sun, the truth is far more subtle and elegant, involving geometry, motion, and the angle at which sunlight reaches the surface of our planet. And as we explore this idea slowly and calmly, we begin to understand that seasons are not random or chaotic, but are the result of a precise and predictable cosmic alignment that changes gradually throughout the year, bringing with it longer sunsets, shorter mornings, gentle breezes, falling leaves, blooming flowers, drifting snow, and the quiet stillness that settles over landscapes during the coldest months. And in this way, the seasons become not just a physical phenomenon, but a reflection of the Earth's journey through space, a reminder that even on the surface of a seemingly stable world, everything is in motion, everything is connected to the flow of light and energy that arrives from the sun, and everything participates in this peaceful cycle of growth, rest, transformation, and renewal that repeats itself again and again, year after year, in a calm and predictable rhythm that allows life to adapt, survive, and flourish within the changing conditions created by the gentle tilt and steady orbit of our planet as it moves silently through the darkness of space, carrying with it oceans, forests, mountains, and all living things through the endless passage of time. While the quiet progression of seasons continues to unfold in a soft and measured way, inviting us to observe the natural balance between light and shadow, warmth and coolness, activity and rest, and to appreciate the deep and fundamental role that this slow cosmic motion plays in shaping the world around us, creating a stable yet ever-changing environment in which life can exist in harmony with the subtle variations of solar energy that define the beginning and ending of each season. As the Earth completes its continuous and unbroken journey around the sun in the vast silence of space, our planet is not flat or perfectly still, but instead exists as a gently curved sphere that rotates slowly and continuously through space, turning upon its invisible axis in a smooth and uninterrupted motion that takes approximately 24 hours to complete one full cycle, creating the peaceful rhythm of day and night that we experience as sunlight gradually arrives and then softly fades away across the surface of the world. And as this slow rotation continues without pause, different regions of the Earth are exposed to varying amounts of solar energy, depending on their position relative to the sun at any given moment. allowing some areas to bask in the warmth of daylight, while others rest beneath the cool calm of night. And this quiet turning of the earth plays a deeply important role in shaping not only our daily experience of time, but also the larger patterns that eventually lead to the formation of seasons, because the spherical shape of the planet ensures that sunlight does not strike every location equally, instead arriving at different angles that spread the sun's energy across wick, D or narrow areas depending on where the light touches the curved surface, meaning that regions near the equator tend to receive more direct and concentrated sunlight, while areas closer to the poles receive light that is more slanted and diffused, gently reducing its warming effect as it travels across a larger portion of the atmosphere before reaching the ground. And as the Earth continues to rotate in this steady and predictable way, the boundary between day and night slowly moves across oceans, forests, deserts, and mountains, carrying warmth into some places while allowing others to cool, creating a delicate balance of energy that shifts continuously yet remains stable over long periods of time. And this rotation also influences atmospheric circulation and ocean currents, guiding the movement of air masses and water in patterns that help distribute heat from one part of the planet to another, supporting ecosystems and maintaining climates that can sustain life. And although the rotation itself does not directly create the seasons, it works quietly alongside the Earth's tilted axis and orbital motion to shape how sunlight is received and absorbed across different latitudes, contributing to the gradual changes in temperature and daylight that define seasonal transitions. And in this way, the simple act of the Earth spinning slowly in space becomes part of a much larger cosmic system in which motion and geometry combine to create the familiar experiences of long summer days, short winter afternoons, blooming springs, and restful autumn evenings, all emerging from the peaceful and continuous turning of a spherical world that moves gracefully through the vast darkness of the solar system, while maintaining the gentle environmental balance that life depends upon, reminding us that even the most subtle and seemingly constant motions can have profound effects over time, as the rotation of the Earth continues endlessly, bringing sunrise after sunrise and sunset after sunset in a calm and measured sequence that quietly supports the dynamic flow of solar energy across the planet's curved surface, helping to prepare the stage upon which the deeper story of seasonal change will unfold as our journey around the sun continues throughout the year, in a silent and harmonious dance of light and motion. As our planet continues its calm and silent journey through space, one of the most important and beautifully subtle features that shapes the changing seasons is the gentle tilt of its axis, an invisible line that runs through the Earth from the North Pole to the South Pole, around which the planet slowly rotates, and instead of standing perfectly upright as it moves around the sun, the Earth is tilted at an angle of approximately 23.5 degrees, a small yet profoundly significant line that quietly determines how sunlight is distributed across different parts of the world throughout the year, allowing some regions to receive more direct light for extended periods, while others experience softer, more angled rays that deliver less concentrated warmth. And as the Earth travels along its orbital path, this tilt remains consistently pointed in the same direction in space, causing different hemispheres to alternately lean toward or away from the sun over time. And when a particular hemisphere is tilted toward the sunlight arriving there becomes more direct, and the days grow longer, creating the gentle warmth and extended daylight that defines summer, while at the same time the opposite hemisphere tilts away, receiving sunlight at a lower angle and for shorter durations, allowing cooler temperatures and longer nights to settle in, marking the arrival of winter in that part of the world. And this gradual shifting of orientation happens slowly and continuously, without sudden change, guiding the peaceful transition from one season to the next in a steady and predictable rhythm that has remained stable for millions of years, supporting ecosystems, influencing weather patterns, and allowing life on Earth to adapt to regular cycles of growth and rest. Because when sunlight strikes the surface of the planet more directly, its energy becomes concentrate, over a smaller area, increasing the warming effect, whereas when the same sunlight arrives at a shallow angle, it spreads across a larger region and must pass through more of the atmosphere before reaching the ground, reducing its intensity and allowing cooler conditions to prevail. And it is this simple geometric relationship between the tilt of the Earth and the angle of incoming sunlight that quietly shapes the familiar experiences of bright summer mornings, crisp autumn evenings, frosty winter nights, and the gentle renewal of spring, all emerging from the steady and unchanging inclination of the planet's axis as it spins and orbits through space, creating a harmonious balance of light and shadow that moves gradually across the globe over the course of a year, ensuring that no region remains in endless warmth or permanent cold, but instead participates in a continuous cycle of environmental transformation that supports biodiversity, agricultural rhythms, and climatic stability. And although this tilt may seem small when measured in degrees, its influence extends across continents and oceans, guiding the seasonal variations that define the natural world and reminding us that even the slightest changes in orientation within the vast geometry of the solar system can produce profound and lasting effects on the surface of a rotating planet, allowing the peaceful progression of seasons to unfold in a calm and measured sequence as the Earth maintains its quiet lean, while traveling endlessly around the sun in the silent expanse of space. As we continue to explore the quiet and graceful motions that shape the changing seasons on our planet, it becomes important to gently understand the difference between two fundamental movements of the Earth known as rotation and revolution, both of which occur continuously and silently in the vast stillness of space, working together in harmony to influence the distribution of sunlight across the surface of the world, yet each representing a distinct type of motion with its own unique role in shaping the rhythms of time and environment. Because rotation refers to the slow and steady spinning of the Earth around its own tilted axis, a peaceful turning that takes approximately 24 hours to complete 4 hours to complete one full cycle, and gives rise to the familiar pattern of day and night as different parts of the planet move into and out of the sun's illuminating rays, allowing warmth and brightness to gradually arrive with sunrise, and then softly fade into cool darkness as evening approaches, while revolution describes the much longer journey that the Earth undertakes as it travels in a wide and gently curved path around the sun, completing this orbital movement over the course of roughly 365 days, carrying the entire planet through the changing positions in space that ultimately lead to seasonal variations in temperature and daylight. And although these two motions occur simultaneously and without interruption, they influence our environment in different ways, with rotation controlling the daily cycle of light and shadow that affects local weather patterns, atmospheric circulation, and biological activity, while revolution works slowly over months to alter the angle at which sunlight reaches different latitudes due to the Earth's axial tilt, allowing some regions to receive longer periods of direct sunlight during certain times of the year, while others experience shorter days and less concentrated solar energy. And it is within this gentle interplay between spinning and orbiting that the deeper story of the seasons begins to unfold, because as the Earth revolves around the sun while maintaining its tilted orientation, the distribution of solar radiation shifts gradually across hemispheres, guiding the peaceful transition from the extended daylight of summer to the quiet stillness of winter, and back again through the renewing warmth of spring and the golden calm of autumn. And even though the rotation of the Earth creates the comforting rhythm of daily sunrise and sunset that we experience as the passing of time, it is the steady revolution, combined with axial tilt, that determines how much sunlight any particular region receives over longer periods, quietly influencing climates, ecosystems, and agricultural cycles in ways that support life across continents and oceans, reminding us that these continuous and predictable movements are not separate forces acting in isolation, but are interconnected parts of a larger cosmic dance in which motion, geometry, and energy come together to create the environmental balance that defines our world, allowing the changing seasons to emerge, not from sudden or random events, but from the calm and enduring partnership between rotation and revolution as the Earth spins upon its axis and journeys endlessly around the sun through the silent darkness of space, maintaining the steady flow of light and warmth that shapes the natural cycles upon which all living systems depend. As our planet continues its calm and silent passage through the vastness of space, it follows a gentle and nearly circular path around the sun known as its orbit, a steady journey that takes approximately 1 year to complete, and forms the foundation of the seasonal changes that quietly transform the natural world over time. Because as the Earth moves along this smooth and predictable orbital route, it carries with it oceans, continents, forests, deserts, and all living beings through different regions of space where the angle and duration of incoming sunlight, HT, gradually shift due to the planet's constant axial tilt, allowing some parts of the world to receive more direct solar energy for longer periods while others experience softer and shorter exposures to sunlight that bring cooler temperatures and extended nights. And although this motion may seem slow and almost imperceptible from our everyday perspective on the surface, it plays a deeply important role in determining how warmth and light are distributed across the globe throughout the year, guiding the peaceful transitions between spring, summer, autumn, and winter in a continuous cycle that has remained stable for millions of years. And as the Earth travels around the Sun in this elegant orbital path, the orientation of its tilted axis remains pointed in the same direction in space, causing different hemispheres to alternately lean toward or away from the Sun at different points along the journey, which in turn influences the intensity and duration of sunlight reaching various latitudes, creating the familiar patterns of longer days and warmer conditions when a hemisphere tilts toward the Sun and shorter days with cooler climates when it tilts away. And it is this quiet relationship between orbital motion and axial tilt that ensures the changing seasons unfold gradually rather than abruptly, allowing ecosystems to adapt to the shifting availability of solar energy that supports plant growth, animal behavior, and atmospheric circulation. And even though the distance between the Earth and the Sun changes slightly during this orbital journey due to the path being gently elliptical rather than perfectly circular, this variation in distance has only a minimal effect on seasonal temperature differences compared to the much greater influence of sunlight angle and day length, reminding us that the story of the seasons is shaped more by geometry and orientation than by proximity alone. And as the Earth continues to revolve in this smooth and uninterrupted manner, the balance of light and shadow moves slowly across the planet's curved surface, guiding the calm progression of environmental change that defines each season and maintains the delicate equilibrium necessary for life to flourish within a dynamic yet predictable climate system, allowing the gentle warmth of summer, the crisp coolness of winter, the renewal of spring, and the quiet reflection of autumn to emerge naturally from the steady orbital dance that carries our world around the Sun in the silent and endless expanse of space, shaping the rhythms of nature through the peaceful distribution of solar energy across time and latitude as the year unfolds in a calm and harmonious sequence of transformation and rest. As we gently continue our exploration into the quiet and fascinating origins of season change, it becomes important to understand a common assumption that may seem intuitive at first, yet does not reflect the true reason behind the warming of summer or the cooling of winter, and that is the idea that the Earth experiences different seasons because it moves closer to or farther from the Sun during its yearly journey through space, when in reality, the slight variation in distance that occurs along the Earth's orbital path has only a very minimal effect on the amount of solar energy reaching the planet's surface, because although the orbit is not a perfect circle but instead a gently elongated shape known as an ellipse, the difference between the closest point to the Sun and the farthest point is relatively small when compared to the immense average distance that separates our world from its central star, meaning that even when the Earth is at its nearest approach, the increase in received solar radiation is not nearly enough to explain the dramatic temperature changes observed between summer and winter in different regions of the globe. And in fact, the Earth is actually slightly closer to the Sun during the time when the Northern Hemisphere experiences winter and the Southern Hemisphere enjoys summer, which would seem contradictory if distance alone were responsible for seasonal variations. Yet this quiet paradox reveals the deeper truth that seasons are governed, not by how far the Earth is from the Sun, but by the angle at which sunlight arrives at the planet's curved surface due to the consistent tilt of its rotational axis. Because when sunlight strikes more directly, its energy becomes concentrated over a smaller area and passes through less of the atmosphere before reaching the ground, allowing it to warm the surface more effectively, whereas when it arrives at a lower angle, it spreads across a larger region and must travel through a greater thickness of atmospheric layers, reducing its intensity and producing cooler conditions. And as the Earth moves along its orbit while maintaining its gentle axial tilt, different hemispheres alternately receive these more direct or more slanted rays of sunlight at different times of the year, creating the gradual and predictable transitions that define the seasonal cycle, allowing longer daylight hours and increased solar concentration to bring warmth during summer months, while shorter days and indirect illumination lead to the calm coolness of winter. And this understanding helps us appreciate that the story of the seasons is shaped more by geometry than by proximity, more by orientation than by distance, as the steady inclination of the Earth's axis quietly determines how solar energy is distributed across latitudes over the course of a year, guiding ecosystems, weather patterns, and biological rhythms in a peaceful and continuous flow of transformation that has supported life on this planet for countless generations, reminding us that even though our world travels through space in an ever-changing orbital path, it is the subtle angle of sunlight rather than the slight change in distance that ultimately influences the environmental conditions we experience, as the familiar progression from the bright warmth of summer to the restful stillness of winter and back again through the gentle renewal of spring and the golden calm of autumn, all emerging from the harmonious interplay between motion, tilt, and the steady arrival of light from the sun as the Earth completes its endless journey around it in the silent expanse of space. As the Earth continues its calm and steady movement through space, the difference between direct and indirect sunlight becomes one of the most important and quietly influential factors in shaping the changing seasons that unfold across the planet throughout the year, because sunlight does not always reach every part of the Earth in the same way. And depending on the angle at which the sun's rays arrive at the curved surface of the world, the energy they carry may either be concentrated into a smaller area or gently spread across a wider region, creating noticeable differences in temperature, daylight intensity, and environmental response over time. And when sunlight strikes the Earth directly, its rays arrive at a steeper angle, allowing the same amount of solar energy to be delivered to a more focused portion of the surface, warming the land, water, and atmosphere more effectively and creating the comfortable conditions, often associated with the longer days of summer, while indirect sunlight arrives at a shallower angle, causing the rays to disperse across a larger area and pass through a greater thickness of the atmosphere before reaching the ground, which reduces the intensity of the energy that ultimately arrives at the surface and allows cooler temperatures to settle in, bringing with them the shorter days and extended nights that define winter in many regions. And this gentle contrast between concentrated and diffused illumination is not random, but emerges gradually as the Earth travels along its orbital path, while maintaining its consistent axial tilt, causing different hemispheres to alternately face toward or away from the sun at different times of the year, allowing one part of the planet to receive more direct sunlight, while the other experiences more indirect rays. And as this balance shifts slowly over weeks and months, ecosystems begin to respond in quiet harmony, with plant growth accelerating in regions that receive more concentrated solar energy and slowing in areas where light arrives at a lower angle, guiding the natural cycles of blooming leaf shedding, dormancy, and renewal that characterize the seasonal rhythm of life, while atmospheric patterns adjust to the changing distribution of heat, influencing wind currents, cloud formation, and precipitation in ways that support the ongoing stability of climates across continents and oceans. And even though the sun continues to shine steadily throughout the year, it is the angle at which its light reaches the Earth that determines how much warmth is absorbed and how long daylight persists in any given location, reminding us that the difference between direct and indirect sunlight plays a central role in the peaceful transition from one season to the next, allowing the familiar experiences of bright summer afternoons, crisp autumn evenings, gentle spring mornings, and quiet winter nights to emerge naturally from the simple geometry of light interacting with a rotating and tilted planet as it journeys silently through the vast expanse of space, carrying with it the dynamic, yet predictable patterns of energy that shape the environmental conditions upon which all living systems depend, ensuring that the changing seasons unfold gradually in a calm and harmonious sequence, guided by the steady variation in how sunlight is received across different parts of the world throughout the year. As we continue to drift gently through the understanding of how seasons form on our planet, the angle at which solar radiation reaches the Earth's surface becomes a quietly powerful factor that shapes the distribution of warmth and light across different regions throughout the year, because even though the sun continuously emits energy in all directions, the way in which that energy is received depends greatly on the angle at which its rays touch the curved surface of our rotating world, allowing some places to receive concentrated warmth, while others experience a softer and more diffused illumination that gently cools the environment over time. And when solar radiation arrives at a steep angle, often referred to as a high angle of incidence. The energy carried by those rays is focused onto a smaller surface area, enabling more efficient heating of land, oceans, and the surrounding atmosphere, creating the comfortable warmth associated with longer days in active ecosystems. While at lower angles of incidence, the same solar energy becomes spread over a much wider area, reducing its intensity and forcing it to pass through a thicker layer of atmosphere before reaching the ground, where some of it is scattered or absorbed along the way, allowing cooler temperatures to settle in and guiding the calm stillness that often accompanies shorter daylight periods. And as the Earth continues its steady orbit while maintaining its nidal axial tilt, the angle of incoming sunlight changes gradually across latitudes over the course of the year, bringing direct radiation to some regions during certain months while causing indirect illumination in others. And this shifting geometry quietly determines how much solar energy any particular location receives over time, influencing seasonal variations in temperature, evaporation rates, wind circulation, and even patterns of precipitation that support life in diverse ecosystems. And it is through this slow and predictable change in solar angle that the familiar progression from the bright warmth of summer to the crisp coolness of winter unfolds, allowing plants to grow more rapidly when sunlight arrives more directly, and to conserve energy when it becomes more slanted, guiding the natural cycles of blooming, dormancy, migration, and renewal that define the rhythm of the seasons, while the oceans absorb and release heat in response to the changing distribution of solar radiation, helping to moderate climate conditions and maintain a stable balance between extremes. And in this way, the angle of solar radiation becomes not merely a geometric detail, but a fundamental influence on the environmental patterns that shape weather systems, biological activity, and the overall energy flow that sustains life on Earth, reminding us that even the smallest changes in orientation between the Sun and our tilted planet can gradually transform the conditions experienced at the surface, allowing the seasons to emerge peacefully from the interplay of motion, light, and atmospheric interaction as the Earth continues its silent journey around the Sun in the vast stillness of space, carrying with it the calm and continuous cycles of warmth and coolness that define the ever-changing yet harmonious environment in which life thrives throughout the year. As we continue to drift gently through the rhythms of Earth's journey around the Sun, the summer solstice emerges as one of the most quietly significant moments of the year, marking the point at which the tilt of the Earth's axis is oriented most directly toward the Sun for a given hemisphere, allowing sunlight to arrive at the steepest possible angle and bathing the land, oceans, and skies in extended periods of warm, concentrated light, creating the longest day and the shortest night of the calendar year. And this subtle celestial alignment does not occur abruptly, but unfolds gradually, with the Sun appearing higher in the sky each day leading up to the solstice, its rays becoming increasingly direct as they sweep across continents, forests, mountains, and bodies of water, encouraging the acceleration of biological processes in plants and animals alike, as leaves unfold fully, flowers bloom, and ecosystems take advantage of the abundant energy that supports growth and activity. While humans historically have observed this moment as a time of harvest, reflection, and celebration, understanding intuitively that the peak of sunlight carries with it a profound influence on life, weather, and energy patterns. And even though the solstice may seem like a simple calendar marker, it is the result of the Earth's constant axial tilt and its steady orbit around the Sun, a slow and deliberate geometry that shapes the distribution of energy across latitudes, ensuring that regions closer to the Tropic of Cancer in the northern hemisphere or the Tropic of Capricorn in the southern hemisphere during its corresponding solstice receive the maximum concentration of solar radiation, while areas farther from the equator still experience increased daylight but with gradually less intensity, creating a natural gradient of warmth and illumination across the planet. And as the days pass beyond the solstice, the tilt remains unchanged, but the Earth's continued orbit slowly shifts the angle of sunlight, allowing the days to shorten imperceptibly and the nights to lengthen, guiding the gradual approach of autumn, while the ecosystems, climate, and human activities respond quietly to this gentle modulation of light and energy, reinforcing the cyclical and harmonious nature of the planet's motion. And in this way, the summer solstice becomes a moment not of sudden change but of quiet culmination, a peaceful reminder of the intricate balance between tilt, orbit and solar radiation, offering a gentle peak of warmth, light, and biological activity that highlights the elegant choreography of Earth in space, allowing life to experience the longest day, the most direct sunlight, and the subtle beginnings of the seasonal transition that will continue in a calm, measured rhythm as the planet completes its endless and silent journey around the sun. As we continue to follow the serene and rhythmic journey of Earth around the sun, the winter solstice emerges as a quietly profound moment, marking the point at which a hemisphere is tilted furthest away from the sun, causing sunlight to strike the surface at its most shallow angle, and delivering the least concentrated energy over the shortest days and longest nights of the year. And although this may feel like a time of stillness and retreat, it is actually a critical phase in the continuous cycle of seasonal change as the low-angle light gently illuminates snow-covered landscapes, quiet forests, and icy lakes, producing soft, elongated shadows that seem to stretch peacefully across the land while temperatures gradually reach their coldest point, signaling a period of rest and conservation for many plants and animals who slow their growth, enter dormancy, or migrate to warmer regions in response to the diminished sunlight. And humans have historically recognized this moment as a time for reflection, gathering in preparation for renewal, understanding intuitively that the winter solstice is the turning point from which the gradual increase of daylight will begin to return, marking the slow, imperceptible start of spring's approach. And like the summer solstice, this event is not abrupt, but a result of the Earth's consistent axial tilt, combined with its steady revolution around the sun, creating a precise geometric alignment that ensures the distribution of solar radiation is at its minimum for one hemisphere while the other experiences the warmth of summer, reminding us that the extremes of heat and cold are orchestrated by angles and orientation rather than distance. And as the days following the winter solstice slowly lengthen, the angle of sunlight increases imperceptibly each day, encouraging gradual shifts in atmospheric patterns, ocean currents, and biological rhythms, allowing life to respond gently to the renewed energy, with sap beginning to rise in trees, animals preparing for breeding or foraging, and humans experiencing a psychological shift as daylight returns incrementally, lifting spirits and preparing societies for the warmer months ahead. And in this way, the winter solstice serves not only as a marker of the year's coldest phase, but as a calm reminder of the harmonious interplay between motion, tilt, and light, demonstrating that even the quietest, darkest days are part of a precise and continuous cosmic cycle that supports life, balances energy across the planet, and ensures that the seasons progress in a peaceful, predictable, and beautifully measured rhythm, allowing the Earth to move gracefully through space while carrying every living thing along its orbit, experiencing the full spectrum of environmental conditions from the long, luminous days of summer to the tranquil, restorative nights of winter, all unfolding naturally from the gentle geometry of the Earth-Sun relationship. As we continue to follow the calm and continuous journey of the Earth around the sun, the spring equinox appears as a moment of quiet balance, a subtle but significant point in the year when the tilt of the Earth's axis is positioned in such a way that sunlight falls almost equally on both the northern and southern hemispheres, producing nearly equal lengths of day and night across the globe. And this gentle equilibrium marks the transition from the cool, restful stillness of winter into the gradual warmth and awakening of spring, signaling to ecosystems, plants and animals that the cycle of growth, reproduction, and renewal is resuming in harmony with the planet's movement as buds begin to swell, and trees, flowers quietly unfold, and migratory creatures sense the increasing energy of the sun, responding instinctively to the subtle changes in light and temperature. While humans have long observed the equinox as a time of renewal, planting, and celebration, recognizing that the balance of day and night offers a moment of reflection and preparation for the longer, warmer days ahead, and this phenomenon occurs not suddenly but gradually, as the Earth continues its steady orbit while maintaining its consistent axial tilt, causing the angle of sunlight to shift progressively across latitudes, moving the peak of winter warmth in the southern hemisphere northward, while bringing longer, more direct sunlight to the northern hemisphere, And it is this precise geometrical interplay between tilt and orbit that quietly orchestrates the equal distribution of light, allowing energy to be balanced across the planet and preparing all living systems for the coming seasons, influencing atmospheric circulation, ocean currents, and climate patterns in subtle ways that affect rainfall, temperature, and ecological cycles, while simultaneously reminding us that even the most tranquil moments in the solar calendar, such as the equinox, are part of a larger, continuous and harmonious system of motion that governs the environment, ensuring that life on Earth experiences the full rhythm of seasonal change, from the rejuvenation of spring to the full warmth of summer, the gentle cooling of autumn, and the quiet dormancy of winter, unfolding naturally as the planet rotates on its axis and revolves around the sun in an endless, serene, and perfectly timed cosmic dance, allowing the gentle transitions of light and energy to guide the cycles of nature, human activity, and the broader environment in a slow, predictable, and beautifully balanced progression that underpins the harmonious flow of life across the globe. Continuing along the serene journey of the Earth around the sun, the autumn equinox emerges as another subtle and harmonious moment of balance, a point in the year when the tilt of the planet's axis is such that sunlight once again falls almost equally on the northern and southern hemispheres, producing nearly identical lengths of day and night across the globe. And this quiet alignment marks the transition from the warm, energetic days of summer into the gradual cooling and reflective stillness of autumn, signaling to plants, animals, and humans that the cycle of growth, activity, and abundance is slowly giving way to a period of conservation, rest, and preparation for the cooler months ahead. As trees begin to change color and shed their leaves in a gentle cascade, crops are harvested in synchrony with the decreasing intensity of sunlight, and animals subtly adjust their behaviors in response to the shifting availability of food and energy. While humans historically have observed this equinox as a time of gathering, reflection, and preparation for winter, understanding intuitively that the balance of light and darkness offers a moment of pause and adjustment in the natural rhythm, and this equilibrium does not happen abruptly, but unfolds gradually as the Earth continues its steady orbital motion while maintaining its axial tilt, causing the angle of sunlight to shift progressively across latitudes, moving the peak warmth of summer away from the northern hemisphere, while providing increasing light to the southern hemisphere, guiding the subtle redistribution of energy that affects temperatures, wind patterns, precipitation, and ecological cycles across the planet. And it is this precise interaction between tilt, orbit, and solar radiation that quietly orchestrates the balance of light and dark, ensuring that living systems can adapt to the seasonal change with resilience, timing, reproduction, migration, and dormancy in harmony with the shifting environment, while the oceans absorb and redistribute heat in response to the gradual reduction of sunlight, helping to moderate climate conditions and maintain a stable global energy balance. And in this way, the autumn equinox becomes a peaceful reminder of the interconnectedness of motion, light, and life, allowing the Earth to continue its endless, graceful orbit around the sun, while all living systems experience the slow and predictable transition from summer's abundance to winter's calm, unfolding naturally in a sequence of diminishing daylight and soft cooling temperatures that guides the rhythm of the seasons with perfect harmony, subtlety, and continuity, demonstrating the elegant geometric and cosmic principles that shape the changing environment across the globe in a calm, measured, and deeply interconnected cycle. As we continue to drift gently through the rhythmic dance of the Earth around the sun, the subtle variation in day length emerges as one of the most quietly influential features of the seasonal cycle, shaping the way light and darkness are distributed across the planet and guiding the timing of natural processes that support life. Because although we often take the passing of hours for granted, the length of daylight changes gradually throughout the year depending on both the tilt of the Earth's axis and its position along its orbital path, causing days to grow longer as summer approaches and shorter as winter nears, with the most extreme differences observed at higher latitudes where, during summer, the sun can remain above the horizon for nearly 24 hours in regions close to the Arctic or Antarctic circles, while in winter, darkness dominates for extended periods, and these gentle changes in day length influence not only the heating of the Earth's surface by controlling the duration of solar exposure, but also the behavior of plants, animals, and humans, as organisms instinctively respond to the availability of light to regulate photosynthesis, feeding, reproduction, and sleep patterns, while human cultures throughout history have recognized these variations as important cues for agriculture, celebration, and daily activity, understanding that the gradual lengthening or shortening of daylight carries profound implications for energy, mood, and productivity. And as the Earth rotates steadily on its axis, while revolving along its orbital path, the combined effect of tilt and revolution produces a smooth, continuous rhythm of day and night that shifts imperceptibly over weeks and months, providing a predictable framework that supports ecological balance and seasonal adaptation, while sunlight's changing duration interacts with atmospheric conditions to influence temperature, wind patterns, and precipitation, subtly guiding the timing of blooms, migrations, hibernation, and harvest cycles. And this gradual modulation of day length also underlies the psychological and physiological responses of humans, as the increasing light of spring and summer tends to energize, awaken, and encourage growth, while the decreasing light of autumn and winter promotes rest, reflection, and conservation. And by understanding this interplay between axial tilt, orbital position, and the resulting variation in day length, we gain a deeper appreciation for the intricate harmony that governs seasonal transitions, allowing the Earth to maintain a balanced distribution of solar energy across its surface, creating the peaceful alternation between light and darkness that defines our experience of the seasons, and reminding us that even the most imperceptible changes in the passage of sunlight carry profound consequences for the rhythm of life, guiding the continuous, silent, and harmonious progression from the long, bright days of summer to the short, quiet nights of winter, and back again in a calm, predictable, and beautifully orchestrated celestial dance that sustains the cycles of nature and life across the globe. As we gently continue our journey through the serene mechanics of Earth's orbit and axial tilt, one of the most fascinating and quietly orchestrated outcomes is the fact that the northern and southern hemispheres experience opposite seasons, a subtle cosmic arrangement that ensures balance and harmony across the planet. Because when the northern hemisphere tilts toward the sun, receiving the most direct sunlight and longest days, it enjoys the warmth and activity of summer, while simultaneously the southern hemisphere, tilted away from the sun, experiences the shorter days, cooler temperatures, and restful stillness of winter. And 6 months later, as the Earth continues its calm progression along its orbital path, the tilt causes the southern hemisphere to lean toward the sun while the northern hemisphere tilts away, creating a perfect inversion of seasonal conditions, a quiet mirror image that repeats predictably year after year, allowing ecosystems, climates, and human activities to adjust in a synchronized yet opposite rhythm. And this alternating pattern is not influenced significantly by the Earth's slightly elliptical orbit, but is instead the elegant result of its consistent 23.5-degree axial tilt, combined with steady revolution around the sun, producing a slow, imperceptible shift in the angle and duration of sunlight across latitudes that guides temperature changes, precipitation, and daylight hours in a coordinated manner across the globe. And as a result, while one hemisphere experiences blooming plants, migrating birds, and growing crops, the other experiences dormancy, hibernation, and preparation for renewal, with polar regions exemplifying the extremes, where continuous daylight during summer contrasts with prolonged darkness during winter, demonstrating the profound effect of tilt and orientation on the distribution of light and energy. And this quiet orchestration affects not only natural systems but also human societies, as agricultural cycles, cultural celebrations, and seasonal activities are aligned with the local experience of sunlight and temperature, yet remain complementary to the opposite hemisphere, highlighting a subtle global symmetry that links distant regions of the planet in a continuous cycle of energy balance and ecological adaptation. And by observing this elegant opposition, we gain a deeper understanding of how motion, geometry, and light interact to create predictable seasonal variation, allowing the rhythms of life to unfold in a harmonious and coordinated way across hemispheres, reminding us that even the vastness of space and the slow motion of our planet can produce precise and balanced outcomes that sustain ecosystems, climates, and human civilization in a calm, rhythmic, and beautifully interconnected celestial dance. As we continue to move gently through the vast and silent mechanics of our planet, the way energy from the sun is distributed across the Earth becomes one of the most subtly powerful forces shaping climate, weather, and the cycle of the seasons. Because even though the sun emits light and warmth uniformly, the curvature of the Earth combined with its axial tilt ensures that this energy is never received evenly at all locations, and instead spreads across the globe in gradients that create warm, equal, equatorial regions, temperate mid-latitudes, and cooler polar areas, and as the Earth slowly rotates on its axis and revolves along its orbital path, the distribution of this solar energy changes predictably throughout the year, giving rise to seasonal variations that guide the growth of plants, the behavior of animals, the movement of ocean currents, and even the flow of winds in the atmosphere. And when sunlight arrives more directly in a concentrated area, such as during summer in a particular hemisphere, energy absorption is greater, warming the surface and initiating complex interactions between the land, water, and air that further redistribute heat, while during periods when sunlight strikes at a shallower angle, energy spreads over a larger area and passes through more of the atmosphere, diminishing its intensity and creating cooler temperatures. And this continuous redistribution of solar energy forms the basis for temperature gradients that drive the circulation of oceans and atmosphere, helping to transport heat from equatorial regions toward the poles in a delicate and balanced system, while the gradual changes in the angle and duration of sunlight throughout the year guide seasonal cycles in ecosystems, agricultural productivity, and human life, ensuring that energy is not concentrated in a single place for too long, but rather flows across the planet in a rhythm that supports the sustainability of life. And even subtle variations, such as the difference in energy received at higher latitudes compared to lower ones, influence the timing of biological processes like flowering, migration, hibernation, and breeding, while the oceans act as giant reservoirs, absorbing, storing, and slowly releasing heat to moderate climates over seasons. And this careful, predictable flow of energy also underpins the contrast between summer and winter, longer and shorter days, and the warmth and coolness experienced at different latitudes, creating a continuous interplay between sunlight, atmosphere, and surface that guides the quiet unfolding of the year, allowing life to adapt, flourish, and rest in harmony with the natural cycles dictated by the tilt rotation and orbit of the Earth. And as we observe this intricate energy balance, it becomes clear that the distribution of solar energy is not random, but a precise cosmic orchestration that ensures the Earth experiences a harmonious sequence of seasons, bringing both warmth and coolness, light and shadow, growth and dormancy, all unfolding naturally in a slow, peaceful, and beautifully balanced rhythm that supports life across the globe in synchrony with the silent, endless journey of our planet around the sun. As we continue our calm journey through the cycles of the Earth, the apparent movement of the sun across the sky becomes a quietly captivating part of the seasonal story. Because although the sun itself remains relatively fixed at the center of the solar system, our perspective from the surface of a rotating and orbiting planet gives the illusion that it rises arcs across the heavens and sets each day a gentle rhythm that not only marks the passage of time, but also signals the subtle progression of the seasons. And as the Earth rotates on its tilted axis, the path of the sun shifts gradually throughout the year, appearing higher in the sky during summer months and lower during winter, influencing the angle at which sunlight reaches different regions, and consequently, the intensity and duration of warmth and light. And this shifting apparent motion is most noticeable when observing sunrise and sunset points along the horizon, which slowly migrate northward or southward over weeks and months, providing a natural indicator of seasonal change to both humans and wildlife. As birds adjust their migratory paths, plants respond with growth cycles, and animals subtly alter behavior according to daylight cues. While humans have long relied on this predictable pattern to track time, plan agricultural activities, and celebrate seasonal festivals, and this movement is not random, but a direct result of the combination of Earth's axial tilt, rotation, and revolution around the sun, creating a consistent and measurable shift that governs the length of days and nights, the distribution of solar energy, and the gradual transitions from one season to the next. And as the sun appears to climb higher or dip lower, the resulting changes in sunlight intensity and duration directly influence temperature patterns, air circulation, and weather systems across the globe, guiding the growth of crops, the timing of animal behaviors, and the overall rhythm of ecosystems, while subtly affecting human psychology, mood, and energy. As longer days bring warmth and activity, and shorter days invite rest and reflection. And in this way, the apparent movement of the sun in the sky becomes more than a simple observation. It is a living indicator of the Earth's ongoing cosmic dance, a gentle visual representation of the axial tilt and orbital motion. That drives the seasons, allowing light, energy, and life to respond in a harmonious and continuous flow, orchestrating the subtle, peaceful transitions that define the passage of the year, from spring to summer, autumn to winter, and back again, in a beautifully balanced, predictable, and soothing rhythm that envelops every corner of the globe in the quiet majesty of the natural cycle. As we drift quietly through the harmonious motions of the Earth around the Sun, one of the most profound and subtly orchestrated effects of seasonal change reveals itself in the response of ecosystems, which are intricately tuned to the gentle shifts in sunlight, temperature, and day length that arise from the combination of axial tilt, rotation, and orbital movement, because every living system, from the smallest microorganism to the largest mammal, is influenced by the timing, intensity, and duration of solar energy received in its particular habitat. And as the Earth tilts toward the Sun during summer months in one hemisphere, ecosystems awaken from dormancy or winter rest, experiencing longer days, higher temperatures, and more direct sunlight that stimulate the growth of plants, which form the foundational energy source for nearly all terrestrial food chains, while the same period triggers breeding and foraging behaviors in insects, birds, and mammals as they respond instinctively to the eased availability of food and favorable conditions. And in contrast, when that hemisphere tilts away from the sun during winter, reduced sunlight, shorter days, and lower energy input lead to the slowing of metabolic processes, dormancy or hibernation in many species, while plants conserve energy, shed leaves, or enter a rest phase to survive the reduced warmth and diminished light, creating a natural rhythm of activity and rest that sustains biodiversity and ensures long-term ecological balance. And this pattern is mirrored in the opposite hemisphere, where the seasons are reversed, illustrating the global synchronization of life with the celestial mechanics of Earth, so that while one half of the planet flourishes in abundance, the other experiences stillness and recovery. And this interplay also extends to aquatic ecosystems, where changes in temperature and sunlight affect water stratification, nutrient cycling, plankton blooms, and the behavior of fish and marine mammals, subtly altering the timing of reproduction, migration, and feeding, while in polar regions, the dramatic seasonal variation in day length, ranging from continuous sunlight in summer to months of darkness in winter, drives extreme adaptations in flora and fauna, from the breeding cycles of seals and penguins to the growth of phytoplankton that forms the base of the marine food web. And even within forests, deserts, grasslands, and wetlands, these solar-driven cycles dictate the timing of flowering, fruiting, seed dispersal, predator-prey interactions, and energy flow across trophic levels, ensuring that each organism is aligned with environmental conditions that maximize survival and reproduction, while climate patterns induced by seasonal energy distribution, such as monsoons, snowmelt, and prevailing winds, further shape ecosystems, such as monsoons, snowmelt, and prevailing winds, creating variation in habitat conditions, water availability, and nutrient flux that organisms have adapted to over millennia. And human societies are also intimately linked to these ecological rhythms, as agriculture, forestry, and fishing practices are planned around predictable seasonal cycles, taking advantage of the periods of abundance and preparing for leaner months, while conservation efforts increasingly rely on understanding the impact of shifting seasons on wildlife migration, breeding, and habitat stability. And in a broader sense, the cascading effects of seasonal changes remind us that ecosystems are finely tuned instruments, responding to a combination of solar energy, Earth's tilt, rotation, and orbital position, with subtle alterations in day length, light angle, and temperature, leading to measurable shifts in plant growth, animal behavior, and energy flow. And these interactions are not isolated but interconnected across terrestrial and aquatic systems, producing complex patterns of adaptation and resilience that allow life to persist in synchrony with the steady rhythm of the planet. And the continuous cycle of spring awakening, summer abundance, autumn preparation, and winter rest emerges as a testament to the seamless integration of celestial mechanics with ecological processes, illustrating that the movements of our planet are not merely physical phenomena, but deeply influential forces that shape life in a calm, predictable, and beautifully orchestrated rhythm, where every sunrise, every shift in sunlight angle, and every gradual change in day length subtly guides the timing, behavior, and survival of all living organisms, creating a dynamic yet harmonious system in which energy flows, ecosystems adapt, and biodiversity thrives, allowing life to respond naturally to the cycles of growth and rest, abundance and scarcity, warmth and coolness, all choreographed by the peaceful and continuous dance of the Earth through space around the Sun, ensuring that the delicate balance of ecosystems is maintained across the globe in a rhythm that is at once silent, enduring, and profoundly life-sustaining. As we continue to explore the quiet and harmonious rhythms of Earth's orbit and axial tilt, one of the most fascinating effects of the changing seasons is the subtle yet profound way humans have adapted physically, behaviorally, and culturally to the predictable variations in sunlight, temperature, and day length that occur throughout the year because from the earliest civilizations to modern societies, people have developed lifestyles, clothing, housing, work schedules, agricultural practices, and cultural traditions that are deeply intertwined with the timing and characteristics of each season. And as the Earth tilts toward the Sun during summer months in a given hemisphere, longer days and higher temperatures encourage increased outdoor activity, extended work hours and daylight, faster growth of crops, and social gatherings, while at the same time humans respond physiologically to the warmth and light, experiencing changes in circadian rhythms, mood, metabolism, and energy levels, with exposure to longer daylight triggering the production of hormones that enhance alertness and activity. And at the same time, during the winter months when the hemisphere tilts away from the sun, shorter days, lower temperatures, and reduced light prompt a shift toward conservation, rest, and reflection, influencing sleep patterns, appetite, vitamin D production, influencing sleep patterns, and psychological well-being. While culturally, humans have historically celebrated this change through festivals, rituals, and practices that align with the turning points of the solar calendar, such as solstices and equinoxes, acknowledging today natural ebb and flow of light and energy, and these adaptations extend into practical aspects of daily life, including clothing designed to provide warmth or cooling depending on the season, homes and buildings constructed to retain heat in winter and allow ventilation in summer, and the timing of planting, harvesting, and food preservation strategies that ensure survival and abundance despite environmental fluctuations, to mix while urban and modern societies continue to respond to seasonal changes by adjusting energy consumption, work patterns, and leisure activities in accordance with daylight and temperature. And even in contemporary times, humans subconsciously respond to the subtle cues provided by changing light and climate, with mood, social behavior, and physical activity influenced by seasonal variation, illustrating that adaptation is not solely cultural, but also biological, driven by evolutionary processes that have shaped human resilience over thousands of years, and this adaptation is mirrored across global populations, with those living closer to the equator experiencing relatively moderate seasonal variation and adjusting to subtle shifts in rainfall and temperature, while populations at higher latitudes contend with extreme variations in day length, temperature, and solar intensity influencing migration patterns, clothing, housing, diet, and energy management strategies. And through centuries, humans have developed technologies, infrastructure, and social systems that mitigate seasonal challenges, including heating, cooling, artificial lighting, water storage, and food distribution, all of which extend the natural ability to cope with the environment, allowing societies to thrive in diverse climates while remaining closely linked to the natural seasonal cycle. And even recreational and cultural practices reflect a deep understanding and respect for these patterns, from winter sports and summer festivals, to agricultural calendars and spiritual observances, demonstrating that human adaptation to the seasons is a multi-layered response, integrating biology, behavior, culture, and technology, finely tuned to the predictable variations in light, energy, and climate created by Earth's axial tilt, rotation, and orbit, ensuring that life continues in balance with natural cycles, maintaining health, productivity, and social cohesion, and highlighting that the changing seasons are not merely an environmental phenomenon, but a deeply intertwined aspect of human experience, shaping the rhythm of life, influencing daily behavior, and guiding societies in harmony with the silent and continuous celestial dance of the Earth around the Sun, providing structure, predictability, and continuity to human existence in a world governed by light, warmth, and time. As we continue to drift gently through the serene and continuous dance of the Earth around the Sun, One of the most profoundly influenced aspects of life on our planet is the agricultural cycle, which is intrinsically tied to the changing seasons and the subtle shifts in sunlight temperature and rainfall that occur due to the Earth's axial tilt and orbital motion. Because the success of farming and food production depends on the predictable timing of growth, flowering, pollination, harvest, and dormancy, all of which are guided by the length of days, the intensity of sunlight, and seasonal temperatures. And as spring emerges with its increasing day length and warming temperatures, farmers and natural ecosystems alike respond to the gentle rise of energy from the sun, with seeds beginning to germinate, young plants absorbing sunlight more efficiently, and the soil warming to levels that allow microbial activity and nutrient cycling to flourish, while insects, birds, and other pollinators become more active, supporting the reproductive processes of flowering plants. And as summer progresses, longer days, higher solar intensity, and adequate warmth provide optimal conditions for crop maturation, enabling grains, vegetables, fruits, and legumes to grow to full size, while irrigation, fertilization, and pest management are carefully timed to match these natural rhythms. And during this period, farmers may harvest fast maturing crops, monitor growth stages, and prepare for multiple planting cycles, while the natural environment thrives with abundant vegetation, supporting herbivores and predators alike. And as the calendar slowly moves toward autumn, the gradual reduction in day length and sunlight angles signals the approach of cooler temperatures, prompting many crops to reach maturity, ripen, and be harvested, while perennial plants begin to store energy in roots and seeds for the coming winter, ensuring survival and regeneration. And this period also triggers behaviors in animals such as fat storage, migration, and preparation for hibernation, mirroring the agricultural preparation of humans for leaner months. And as winter arrives, shorter days, low temperatures, and diminished sunlight lead to dormancy in many plants, a pause in microbial activity in soil, and a slowdown in human fieldwork, with stored food, preserved grains, and winter crops providing sustenance until conditions improve, illustrating the crucial interplay between celestial mechanics and agricultural planning. Because the tilt of the Earth, the angle of sunlight, and the resulting seasonal cycles create a framework that humans have adapted to over thousands of years, aligning sowing and harvesting schedules, breeding livestock, and managing water and soil resources in harmony with natural rhythms. And this relationship is evident not only in traditional farming practices, but also in modern, technologically assisted agriculture, where knowledge of seasonal patterns informs greenhouse management, crop rotation, planting schedules, pest control, and irrigation strategies, allowing optimization of yields while maintaining ecological balance. And even in regions with less pronounced seasons, the subtle changes in day length, temperature, and precipitation guide planting cycles and productivity, demonstrating that agriculture is fundamentally an adaptation to the timing and intensity of solar energy distributed across the Earth's surface, influencing every decision made in the growth, harvest, and storage of food, while simultaneously shaping the surrounding ecosystems, supporting pollinators, seed dispersers, and soil organisms, and reinforcing the idea that the changing seasons are not merely abstract environmental phenomena, but practical guides for sustaining human life and the health of our planet, ensuring that the rhythms of planting, growth, and harvest unfold predictably in sync with the sun's movements, the Earth's tilt, and the passage of time, providing a steady, reliable pattern upon which civilizations have depended for millennia, and reminding us that the silent, continuous journey of the Earth through space governs the very foundation of human survival, food security, and the harmonious interaction between agriculture and natural ecosystems in a beautifully orchestrated cosmic and ecological cycle. As we continue to drift gently through the seamless and silent rhythms of Earth's orbit and axial tilt, one of the most fascinating demonstrations of life's adaptation to the changing seasons is the migration patterns of animals, which are intricately synchronized with the predictable variations in sunlight, temperature, and resource availability that result from the planet's axial tilt and orbital motion. Because countless species, from tiny insects to enormous mammals and birds, rely on the gradual and rhythmic changes in environmental conditions to guide their movements across continents, oceans, and skies, ensuring access to food, breeding grounds, and suitable habitats, and as the Earth tilts toward the sun during the summer months in one hemisphere, regions experience longer days, warmer temperatures, and increased abundance of vegetation and prey, signaling to animals that it is the optimal time to migrate toward these areas to feed, breed, and raise offspring, while simultaneously the opposite hemisphere, experiencing winter with shorter days, cooler temperatures, and reduced food availability, triggers migration away from those areas, creating a continuous and complementary movement between hemispheres, and this pattern is evident in countless species, from monarch butterflies following flowering cycles, to wildebeests tracking grass growth across the African savannas, to Arctic terns traveling thousands of miles between polar regions to exploit summer abundance, with each species responding to subtle cues in temperature, day length, and solar angle that inform instinctual timing and routes, and the gradual transitions in light and warmth ensure that migrations are not abrupt or haphazard, but carefully timed to coincide with optimal environmental conditions, reducing mortality and maximizing reproductive success, while also balancing predator-prey relationships, nutrient cycles, and ecosystem dynamics along migratory corridors. And even marine species exhibit similar adaptations, with fish, whales, and plankton responding to seasonal changes in ocean temperature, current patterns, and productivity, following shifts in phytoplankton blooms and nutrient availability that are dictated by sunlight intensity and seasonal cycles. And these predictable movements reinforce the interconnectedness of ecosystems, allowing energy, nutrients, and organisms to flow across habitats in harmony with the planet's changing seasons. While humans have historically observed and, in some cases, depended on these migration patterns for food, cultural practices, and ecological understanding, aligning agricultural, fishing, and conservation efforts with the movements of wildlife, and modern science continues to reveal the astonishing precision with which species navigate using celestial cues, geomagnetic fields, and environmental signals that are all influenced by the Earth's tilt, rotation, and orbit, demonstrating that migration is not merely a behavioral response, but a deeply integrated adaptation to the planet's seasonal energy distribution, guiding life in a quiet, continuous, and highly synchronized flow, ensuring survival, reproduction, and ecological balance across the globe, and highlighting that the silent, predictable movement of the Earth through space orchestrates complex patterns of behavior and adaptation in ways that are both elegant and essential, allowing millions of species to track resources, avoid harsh conditions, and thrive in a rhythm that mirrors the slow, harmonious, and beautifully measured dance of the seasons, reinforcing the idea that the cycles of nature, life, and migration are deeply rooted in the cosmic geometry of our planet's orbit and tilt, producing a balanced, resilient, and enduring ecological system that responds to the subtle yet powerful influences of light, temperature, and time. As we continue to glide gently through the serene cycles of the Earth's orbit and axial tilt, one of the most fascinating and quietly essential adaptations to seasonal change is the phenomenon of hibernation and dormancy, which allows countless species from small mammals and amphibians to insects and perennial plants to survive periods of reduced sunlight, lower temperatures, and limited food availability that accompany winter in temperate and polar regions, because the gradual decrease in daylight, the shallow angle of solar radiation, and the cooling of air and soil signal to living organisms that metabolic activity, growth, and resource consumption must be slowed or temporarily suspended to conserve energy. And for animals, hibernation is a complex physiological process triggered by environmental cues such as shorter days, lower temperatures, and declining food resources, leading to a profound reduction in heart rate, respiration, and metabolic activity, allowing species such as bears, ground squirrels, bats, and hedgehogs to survive months without feeding while maintaining just enough energy to endure the winter, while birds, fish, amphibians, and reptiles may enter forms of dormancy or torpor, seeking shelter in burrows, under leaves and water bodies, or within soil to avoid the harshest conditions, all orchestrated in precise alignment with the seasonal progression dictated by Earth's tilt and orbit. And for plants, dormancy involves the temporary cessation of growth and photosynthesis in response to low temperatures and reduced sun light, with deciduous trees shedding leaves and storing nutrients in roots, bulbs, or seeds to withstand the cold months, while perennials pause above-ground growth and annuals complete their life cycle before the onset of winter, ensuring survival until conditions improve. And these processes are not abrupt but unfold gradually as the angle and intensity of sunlight decrease and night length increases, providing organisms with a predictable environmental framework upon which to schedule rest, energy conservation, and protection from external stress. And this synchronization of dormancy and hibernation with seasonal cycles has profound ecological consequences, influencing predator-prey dynamics, nutrient cycling, and the timing of growth and reproduction. When spring returns, as the emergence of plants, insects, and animals coincides with increasing sunlight, warmer temperatures, and the availability of food, creating a cascading effect that supports entire ecosystems, and humans too have historically observed these patterns, relying on knowledge of animal behavior and plant dormancy for hunting, agriculture, and the management of natural resources, while modern science continues to study hibernation as a model for medical research, energy conservation, and understanding the delicate interplay between physiology and environment, demonstrating that the quiet, deliberate rhythms of the earth govern the timing of life's pauses and awakenings in a deeply integrated and essential way, and the predictable onset of hibernation and dormancy exemplifies the profound influence of solar geometry, day-length variation, and seasonal energy distribution on living systems, ensuring that organisms not only survive but thrive in alignment with the cycles of nature, highlighting the elegance, precision, and balance of the natural world, and reminding us that even the coldest, quietest months are part of a continuous, harmonious, and beautifully orchestrated process where the tilt, rotation, and orbit of the Earth guide life in a slow, predictable rhythm of rest and renewal, sustaining the interconnected web of ecosystems in a calm, resilient, and profoundly life-supporting cycle that unfolds silently day by day, season by season, year after year, as we continue to drift peacefully through the intricate dance of Earth's orbit and axial tilt. One of the most quietly remarkable manifestations of seasonal change is the way plant life cycles are meticulously aligned with the predictable variations in sunlight temperature and moisture that occur throughout the year. Because plants as primary producers rely directly on these environmental cues to regulate growth, flowering, fruiting, seed production, and dormancy, ensuring that energy from the sun is harnessed efficient, and that reproduction occurs under optimal conditions. And as spring emerges with longer days and warmer temperatures, seeds begin to germinate, roots extend into the warming soil, and young shoots reach upward toward the increasing intensity of sunlight, while leaves unfurl to maximize photosynthesis, allowing plants to convert solar energy into chemical energy that fuels growth and supports entire ecosystems. And during summer, when day length and solar intensity reach their peak in a given hemisphere, plants capitalize on the abundance of light and warmth to complete flowering, produce fruits, and accumulate resources in stems, roots, and seeds, timing these processes precisely so that pollinators such as bees, butterflies, and birds can interact with flowers, ensuring successful reproduction. And this intricate coordination with pollinator behavior highlights the interdependence of species that has evolved in response to the cyclical patterns of the sun, Earth's tilt, and seasonal energy distribution, while in autumn, decreasing day length and declining temperatures trigger maturation of fruits, seed dispersal, and preparation for winter, with the deciduous trees shedding leaves to conserve water and nutrients, perennials storing energy in underground structures, and annuals completing their life cycle, ensuring that offspring are ready to germinate when favorable conditions return. And during winter, low light intensity and short days induce dormancy in many plants, slowing metabolic processes and allowing survival through periods of scarcity, while root systems, seeds, and bulbs remain poised to respond to the gradual return of warmth and sunlight in spring. And this cyclical alignment with seasonal change not only regulates individual plant life cycles, but also shapes entire ecosystems, influencing food availability for herbivores, supporting the timing of migrations, and guiding the interactions of predators and prey, while soil microbes and fungi respond to temperature and moisture changes that accompany seasonal shifts, facilitating nutrient cycling that sustains plant health and productivity. And humans too have historically observed and depended on these seasonal patterns for agriculture, harvesting, and forestry, developing calendars, planting schedules, and preservation strategies in tune with the natural rhythm of plant life, while modern science continues to explore how photoaperiod temperature and solar radiation regulate growth cycles, stress responses, and reproductive timing, highlighting that the cycles of plant life are not arbitrary, but a direct reflection of the precise geometry and energy distribution of the Earth-Sun system, ensuring that ecosystems function in a harmonious, resilient, and predictable manner. And by understanding these cycles, we appreciate how the tilt, rotation, and orbit of the Earth orchestrate the timing of growth, dormancy, reproduction, and renewal, producing a balanced rhythm that supports life, sustains biodiversity, and maintains the continuity of ecological processes, illustrating that the changing seasons are deeply woven into the very fabric of plant existence, silently guiding the progression of life from seed to sprout, bloom to fruit, and dormancy to renewal, in a slow, harmonious, and beautifully measured cosmic and ecological dance that persists year after year across the globe. As we continue to drift gently through the serene and continuous journey of the Earth around the Sun, one of the most quietly powerful influences of seasonal change is the effect it has on the global water cycle. Because the tilt of the Earth, its orbital motion, and the resulting variations in sunlight, day length, and temperature orchestrate the timing and intensity of evaporation, condensation, precipitation, runoff, and groundwater recharge, which in turn shape the availability of fresh water for ecosystems, agriculture, and human societies. And as spring arrives in a given hemisphere with longer days and warmer temperatures, snow and ice begin to melt in polar and mountainous regions, releasing stored water that gradually replenishes rivers, lakes, and aquifers, while increasing warmth and sunlight drive higher rates of evaporation from oceans, lakes, and soil, adding moisture to the atmosphere and supporting cloud formation. And as summer progresses, warmer temperatures and longer days intensify evaporation, which, combined with seasonal wind patterns and atmospheric circulation, leads to predictable rainfall events such as monsoons, thunderstorms, and convective showers, nourishing plant life, replenishing soil moisture, and maintaining the hydrological support essential for both terrestrial and aquatic ecosystems, while simultaneously influencing the behavior and distribution of animals that rely on water for drinking, breeding, and habitat. And in autumn, as day length decreases and temperatures gradually cool, evaporation rates decline, precipitation patterns shift, and water stored in vegetation, soil, and reservoirs begins to accumulate more predictably, providing stability to ecosystems and supporting the preparation of organisms for winter. While in winter, reduced sunlight and low temperatures limit evaporation and often result in snow accumulation, ice formation, and frozen water bodies that temporarily restrict water availability but preserve it in a stable state until the return of spring. And this cyclical pattern of seasonal water movement is not merely a surface phenomenon but extends into complex interactions between groundwater recharge, because river flow, ocean currents, and atmospheric moisture transport, which together maintain a dynamic balance of water across the planet, supporting life, moderating climate, and regulating ecological processes. While humans have historically relied on these seasonal water cycles to plan agriculture, manage irrigation, anticipate floods and droughts, and maintain access to clean water, and modern hydrology continues to reveal the subtle influence of solar angle, day length, and seasonal energy distribution on evaporation, precipitation, snowmelt, and groundwater flow, demonstrating that water availability is directly tied to the celestial mechanics of the Earth-Sun system. And as the seasons progress, this precise timing ensures that plants receive sufficient moisture. During growth phases, animals have access to hydration and breeding grounds, and societies can sustain agriculture, sanitation, and energy production, while variations in precipitation and runoff subtly shape soil fertility, sediment transport, and nutrient cycling, reinforcing the interconnection between water ecosystems and climate. And ultimately, the seasonal effects on water cycles illustrate the elegant harmony between the movement of our planet and the sustenance of life, showing that the quiet and predictable progression of the Earth through space governs not only temperature and daylight, but also the essential flow of water, orchestrating evaporation, precipitation, and storage in a slow, continuous, and balanced rhythm that nourishes life, maintains ecological stability, and supports the intricate web of natural processes that make the planet habitable, reminding us that every snowflake, rainfall, and river current is subtly guided by the tilt, rotation, and orbit of our planet in a beautifully measured, silent, and life-sustaining celestial and terrestrial cycle. As we continue to drift softly through the harmonious cycles of Earth's orbit and axial tilt, one of the most quietly intricate ways that life responds to the changing seasons is in the timing and success of animal reproduction, because the predictable variations in sunlight, temperature, day length, and resource availability that accompany seasonal change create the precise environmental conditions necessary for mating, gestation, nesting, and rearing of offspring. And as spring arrives in a given hemisphere, with increasing daylight and warming temperatures, many species instinctively initiate reproductive behaviors, from courtship displays and vocalizations to territorial marking and nest building, responding to hormonal cues triggered by the gradual lengthening of days and the rise in solar intensity, while simultaneously the availability of food and suitable habitats increases, ensuring that both parents and young have access to the energy necessary for survival. Enduring summer, peak sunlight and warmth support the growth and development of young, with longer days providing more time for foraging, feeding, and protection, while plants and prey species flourish, offering a stable and abundant food supply that maximizes the chances of survival for offspring. And in contrast, as the year progresses into autumn and day length decreases with cooler temperatures, reproductive cycles begin to wind down. Gestation periods conclude, controlled young prepare for independence, and energy conservation becomes increasingly important. While in winter, many species enter states of reduced reproductive activity or complete dormancy, relying on stored energy and environmental shelters to survive until conditions improve, and this precise timing is evident in countless species, from insects whose eggs are laid to coincide with plant growth cycles, to birds whose migration aligns with breeding in optimal climates, to mammals whose gestation ensures that offspring are born when temperatures are moderate and food is abundant, demonstrating the tight integration of life cycles with seasonal cues, while marine species, amphibians, and reptiles similarly respond to temperature and light changes, timing spawning, hatching, and larval development to coincide with optimal ocean currents, rainfall, and resource availability. Why? Ensuring that young can survive and thrive in their complex and interconnected environments. And these reproductive rhythms are not merely biological, but ecological, influencing population dynamics, predator-prey interactions, and community structure, as the birth and survival of one generation affects resource distribution, competition, and the timing of future cycles. While humans have historically observed these patterns to anticipate hunting seasons, livestock breeding, and food availability, aligning agricultural and social practices with the reproductive cycles of animals, and modern science continues to explore how photoperiod temperature and energy availability regulate reproductive hormones, behavior, and developmental timing, revealing that animal reproduction is a finely tuned response to the celestial mechanics of the Earth-Sun system, with subtle shifts in sunlight, day length, and temperature orchestrating complex behaviors that ensure the survival and continuation of species while maintaining ecological balance. And ultimately, the seasonal effects on reproduction demonstrate the elegance and precision with which life on Earth synchronizes itself with the quiet, predictable, and continuous rhythms of our planet, allowing generations of animals to emerge, thrive, and reproduce in harmony with the tilt, rotation, and orbit of the Earth, creating a beautifully orchestrated cycle of birth, growth, and renewal that sustains biodiversity, ecosystems, and the intricate web of life across the globe in a calm, rhythmic, and life-sustaining pattern that unfolds year after year. As we reach the final point in our gentle exploration of the Earth's tilt, orbit, and the resulting dance of the seasons, one of the most profoundly enlightening observations is the remarkable interconnectedness of all seasonal phenomena, because the subtle shifts in sunlight temperature, day length, and energy distribution caused by Earth's axial tilt and revolution around the sun ripple through every aspect of life and environment, linking climate, ecosystems, animal behavior, plant life cycles, water movement, human activity, and even cultural rhythms into a single, harmonious system that responds predictably to celestial mechanics. And as spring emerges, the increasing solar energy awakens dormant plants, triggers migratory patterns in birds and insects, initiates reproductive cycles in countless species, replenishes rivers and lakes through snowmelt and rainfall, and encourages human agricultural activity and cultural celebrations, while summer, with its peak sunlight and extended days, maximizes growth, abundance, and productivity, supporting the maturation of crops, the development of young animals, the full activity of ecosystems, and the energetic engagement of human societies. And as autumn gradually arrives, the slowly decreasing day length and cooling temperatures guide the ripening of fruits, the preparation of animals and humans for winter, the harvesting of crops, and the storage of energy both biologically and culturally, while winter, with its short days, low solar angle, and dormancy-inducing conditions, enforces periods of rest, conservation, and renewal across both natural and human systems, illustrating that each season is neither isolated nor random, but an integrated part of a global cycle in which energy, light, water, and biological activity flow seamlessly from one stage to the next, and this interconnection extends beyond immediate ecosystems, influencing ocean currents, atmospheric circulation, nutrient cycling, predator-prey dynamics, and the timing of life events across species and biomes, while humans, through centuries of observation, have aligned calendars, agriculture, architecture, agriculture festivals of observation, and social organization with these predictable rhythms, acknowledging intuitively that survival, productivity, and cultural continuity depend on being in harmony with seasonal transitions, and modern science continues to reveal the depth of these connections, showing that changes in sunlight and temperature affect plant photosynthesis, animal migration, hibernation and reproduction, hydrological cycles, soil, nutrient, dynamics, and even global climate patterns in ways that are subtle yet profoundly interdependent, while shifts in one element of the system, such as early snowmelt or delayed monsoons, can cascade through ecosystems, affecting food availability, species interactions, and human livelihoods, emphasizing that the seasons are part of a complex, finely tuned network of cause and effect, and the beauty of this interconnectedness is that it unfolds naturally and predictably, allowing life to anticipate, adapt, and thrive in synchrony with the Earth's movement through space, producing a rhythm that is at once silent, enduring, and profoundly sustaining. And by observing and understanding these links, we appreciate that the tilt, rotation, and orbit of our planet are not merely astronomical facts, but the underlying framework that governs ecological stability, biological timing, energy flow, and human adaptation, weaving together light, warmth, water life, and culture into a single continuous pattern, so that from the awakening of spring to the dormancy of winter, every living system, every seasonal process, and every ecological and human activity participates in a magnificent interconnected dance guided by celestial mechanics, producing balance, resilience, and continuity in a world that is both dynamic and harmonious, demonstrating that the seasons are not separate events but thread in a unified global and timeless tapestry, in which the cycles of light, growth, rest, and renewal sustain life across the planet, and reminding us that every sunrise, every shift in sunlight, every bloom, migration, and harvest is part of a vast, elegant, and interconnected system orchestrated by the slow, deliberate, and perfectly measured motion of the Earth through space around the Sun, creating a calm, rhythmic, and life-sustaining cycle that continues endlessly year after year, linking all phenomena in a seamless and profoundly beautiful celestial and ecological harmony.